So Sarah walks from her home to the store. Halfway to the store, she realizes she forgot to bring money, so she turns around, returns home, gets her money, and then walks all the way to the store. Graph time on the x-axis. Time is always an x value, and distance from home on the y-axis. Okay, so that's really important to label your x and y axis, especially with time on the x axis. We're getting ready to talk about that for just a second. So I'm going to do this graph 3 times. I'm going to do a completely incorrect graph, and then I'm going to do a kind of correct graph, but not precise and not entirely realistic. And then I'm going to do a pretty realistic and precise graph. So this is completely incorrect. So start thinking as I'm doing this why it's incorrect, and then we'll talk about it. So she walks from her home to the store. Halfway to the store, so there's about halfway, she realizes she forgot to bring money, so she turns around, goes back home, gets her money, and then walks all the way to the store. Okay, so let's talk about why this graph is totally, completely wrong. Because it's all about time. We cannot stop time, we cannot reverse time, we cannot go back in time. So basically, if you look right here, we're at 3 different distances. So 3 different distances at the exact same time. So say this is 5 minutes into a trip. We can't be 10 feet from home, 20 feet from home, and 60 feet from home all at the same 5 minute mark. That's just not physically possible. So this graph right here, the origin does represent at home, but that's at home at time, only at time 0, right? So she goes back home, which she does, that's going to be at another time, not at time 0. So we can't come back to the origin, okay? So let's talk about how to fix that. So let me fix my graph here real quick. Distance from home. Okay, so just keep in mind as you're drawing these graphs, time has to keep moving on. So I have to keep going to the right, okay, because I can't stop time, can't go back in time. So she's at home. She gets about halfway. Now, here's the cool thing with this graph. You do get a little bit of personal choice here. So your line doesn't have to be as steep as mine. It could be a little bit flatter. So maybe she's walking a little bit slower. Maybe she's walking a little bit faster. She's getting farther away from home quicker. Or she's getting farther away from home slower. So you get some personal choice there. So then she turns around, but time keeps going on. She goes back home, so her distance from home is 0. So again, is that line going to be steeper? Is she hurrying now because she's losing time? Is she still walking slow? Is she walking the same pace? So you get a little bit of choice with steepness here, okay? So back home, distance from home is 0, but again, time keeps moving on. Away from home, back to home. Then she goes all the way to the store. Okay, now something important to keep in mind, she gets halfway to the store. So make sure this is about half of your total distance here. All right, so now let's talk about why this is still not totally correct and still not the best graph that we could come up with. Okay, so let me point out here. So she's walking to the store. She forgets her money. Goes back home. Then here she gets her money. I don't have room to write that. And then she goes to the store again. So going to the store, forgets money, back home, gets money, goes to the store. So I want you to think about this, okay? Here, she immediately turns around. So it's like she's walking. I forgot my money, immediate about face, back home. That's not realistic because she's probably going to either A, slow down a little bit and think, do I have my money? She might even stop and look in her purse or her bag for money. So she may even stop where she stands. So this peak right here is not realistic because this shows just a sharp turnaround, which is Probably not going to happen. Plus, this right here, this low peak right here, means that she went home and immediately left again. Well, isn't she going to have to look for her money, or, at least open her door and go in and get it and close her door and lock it? So these sharp peaks are not realistic. Okay. They're not going to be immediate turnarounds like that. So let's talk very precise. Okay. And again, you have some personal choice. Not everybody's graphs are going to be 100% the same, but this general idea. So she's starting from home. You get to decide her speed or her steepness. I'm going to decide that she kind of slows down a little bit, like, wait a minute, I think I forgot my money. And then I'm going to have her stop and look for it. That's going to be this little flat space. So what this is going to mean is that she stops to look. And how we know she stops is time has to keep moving on, right? Time keeps trucking, but she has stopped where she stands and her distance from home is not changing. So whatever distance from home she is right here, she's going to stay there until she's like, oh yeah, I really did forget my money. Let's go back home. I'm going to have her walk a little bit faster because now she's kind of mad. Then when she gets home, she has to at least go in the house and look. So there's going to be a little flat space down here at the bottom. She's going to be at home for a minute or two. So that's what this flat space is. Again, time has to keep trucking. We have to show time, keep moving on. So she's found her money, and then let's have her go all the way to the store, making sure that's about halfway of the whole thing. So this is getting her money. Okay, so to the store, forgets, stops to look, going back home, at home getting her money, and then going all the way to the store. And then you actually have a little personal choice here. Do you want to show her at the store? So again, her distance from home is not going to be changing because she's there at the store. So you have a little bit of personal choice here, but some things are non-negotiable. Like, those sharp peaks just weren't precise enough for our graph, but there is some personal choice here.